I'm Devin Crowder.
And I'm Madison.
And we did wastewater.
So Devin and I visited a water treatment plant facility, and we met with a very sweet lady and just asked her a few questions about how it works. So our first question was, how would you define wastewater treatment and why is it important?
And she told us that it consists of natural and biological functions alongside mechanical processes that work on a continuous flow-through basis, and that it's important because it improves the waste stream to an environmentally safe waste matter.
So our second question is, where is it discharged?
She informed us that the facility discharges the water into the East Fork of the White River.
So then we asked her what are the steps. We could compare them to the steps we learned through the book. And we learned that pre-treatment is where the paper, plastic, and grit gets removed. And then the primary treatment is what reduces the solids and the BOD, which is the biochemical oxygen demand, for the aeration in phase 3. Then there, phase 3 is the secondary treatment, which is the process named aerated activated biosolid to complete the reduction of pollutants in the water in the waste stream. And then the final clarification is where solids are separated from the finished water with the solids return system. And the disinfection is the ultraviolet light exposure for cell destruction. And these steps differed from the steps that we learned through our book, which are because wastewater is anything polluted in your house. In developed countries and municipalities, they use centralized sewage treatment plants that receive the wastewater from hundreds or even thousands of households via underground pipes. So the first step in our book we learned about was that underground pipes carry waste to the treatment plant. And then large debris filtered out by the screens are sent to the landfill. And then third, solid waste settles to bottom of tanks. Fourth, bacteria break down organic material to carbon dioxide and inorganic nutrients, settled particles added to sludge. And then the sludge is thickened by removing water. And the thickened sludge taken to a landfill, burned, or used for fertilizer. And those are the three steps, or those are the three things that can happen to the waste. And then seventh step, exposure to chemicals or ultraviolet light kills pathogens. And eighth, treated water released into river or lake. So now we have a demonstration over the water treatment cycle, and we're gonna do that.
Wait, the audio.
Okay. So what we're gonna do here, we have this in the primary treatment, and you can see that we have floating things and some things that are sinking, which shows the waste. Like this is kind of like poop, and like just like things that would go through
waste.
The underground thing, okay? And then this right here is going to be like primary treatment where the solids will be filtered out, and so we're going to demonstrate that really quick.
Okay. Bye-bye, poopy.
Okay, so then this is the stuff that would be sent off to be incinerated, burned, for use for fertilizer, because this is the stuff that no one really wants in their water. And then we would take a little bit of chemicals or ultraviolet light and dump it in there to make this okay to send back into something like the East Fork of the White River. So now we're going to continue with our presentation. Okay, so then now we have the water cycle. And the water cycle is the movement of water through the biosphere, is known as the hydraulic cycle. Heat from the sun causes water to evaporate from oceans, lakes, and solids. Solar energy also provides the energy for photosynthesis, during which plants release water from their leaves into the atmosphere through transpiration. The water vapor that enters the atmosphere eventually cools and forms clouds, which in turn produces precipitation in the form of rain, snow, or hail. Then it can take 1 to 3 routes. The first is either evaporation or transpiration as it returns to the environment, or the atmosphere. The second is that water can be absorbed into the soil and percolate down into the water. Third, water can move off as runoff, ultimately reaching the ocean, then it evaporates and begins again. So now we have a poster to just kind of like show the class, or just you, Mr. Rice, about just how the water cycle really works. Okay.
This is our demonstration of it.
So you can see that so it starts mostly with evaporation, with like the ocean and like rivers here too, and it goes up, and in the clouds is condensation, and it turns into precipitation as like hail, sleet, snow, rain, whatever, and it comes off, and it either goes off into surface runoff and gets back into the ocean, which it starts a whole cycle again. And also through trees, the energy can go through transpiration and also just starts the whole cycle again. So it's just this whole cycle revolving. Okay?
Right
on. Okay. And the water cycle relates to what we're talking about with the water treatment center, because the water treatment center is like about water like going through a cycle of like this, a flow through basis is what the lady told us. Like it goes through the cycles, and so the water cycle just like it also goes through steps, and it's the flow of water just like the wastewater treatment is. Okay? So next we have aquifers.
So aquifers are sources of usable groundwater. The two most common types would be confined and unconfined aquifers, and the difference being is that unconfined aquifers receives water directly from the surface, while confined aquifers, the water is trapped between two layers of impermeable rock or clay. And the water in confined aquifers is often under extreme pressure, and a way to relieve that pressure is to drill holes into the confined aquifer, so then water shoots up and creates an artesian well. And then this is our demonstration of confined and unconfined aquifers. The two brown layers on the bottom are the impermeable layers of rock and clay, and in between those two is the confined aquifer. And then the artesian well goes down into the confined aquifer and shoots up water right here. And then the second layer of blue is the unconfined aquifer, which the water is directly receivable from the water table, which could be like a river or a stream. And then also for the confined aquifer, the water goes into it through a recharge area on the surface.
And next we have chemical and non-chemical water pollution.
Water pollution is defined as the contamination of streams, rivers, lakes, oceans, or groundwater with substances produced through human activities that cause harm to the environment and to organisms. Chemical pollutants include diseases, oil, and wastewater, all of which pose extreme threats to human health and the environment, organisms, all of the above. And then the non-chemical pollutants include thermal pollution, which is human-induced and it causes changes in water temperature, which it can kill many species because they're often incapable of adapting to differences in water temperature. And then another kind of non-chemical pollutant is noise pollution, which is emitted by ships and submarines and can interfere with animal communications, which obviously poses a threat to their survival if they aren't capable of communicating.
And so that was our presentation, and we hope you have a great summer, Mr. Rice. Bye!
Bye.